Here I want to talk about indices and tell you what sort of rules they follow. And indices are just ways of writing repeated multiplications. For example, if you've got 3 times 3 times 3 times 3, you can write that more simply as 3 to the power of 4. The power of 4 means 3 multiplied by itself 4 times. The main use for indices is in powers of 10, 1,000, can be written as 10 to the power of 3, a million can be written as 10 to the power of 6, a billion can be written as 10 to the power of 9. When we're writing indices, all of the numbers have to be the same sort. So, for example, 3 times 3 times 3 times 3 equals 3 to the 4. We call 3 the base. Okay. And index notation, all of the multiplications have to be the same base. So you can't have 3 times 3 times 4 equals 3 to the whatever. It doesn't work. If we write b for our base, then we have a number of rules. The first one is b to the power of p times b to the power of q is b to the power of p plus q. So under multiplication, the indices add. B to the power, when you multiply two identical bases to different powers, you just add the powers. The second rule is for division. B to the power of p divided by b to the power of q is b to the power of p minus q. The third fact about indices is b to the power of 0 equals 1 unless b is 0 itself, in which case it isn't a number. B to the power of a minus index is the same as 1 over b to the power of a positive index. B to the power of p, then all to the power of q is the same as b to the power of p times q. And the last one, a little bit more complicated than the rest, b to the power of 1 over p is the pth root of b. Okay, so how are we going to demonstrate that all of these things are true? If you just want to know these facts, here they are. The rest of the video is about showing that they're true. Okay, let's look at the first rule. B to the power of p times b to the power of q equals b to the power of p plus q. This one's pretty easy to prove, it just works by the definition. B to the power of p is just b times itself, p times, so we'll go p times b times b times times b. There are p copies there. B to the power of q is b times b times b. There are q copies there. We multiply them together, we can see that there's p plus q copies together, and so by the definition, that's just b to the power of p plus q. Okay, rule number 2, b to the power of p divided by b to the power of q equals b to the power of p minus q. Well, we can do this as a fraction. b to the power of p divided by b to the power of q is just b to the power of p over b to the power of q, and then we can use the definition. That's b times b times b, that's p of them up the top there, divided by b times b, that's q of them there. So we can cancel out the b's. And how many b's can we cancel? We can cancel out 1 b from top and bottom, 1 b, 2 b's from top and bottom, 3 b's from top and bottom, q b's from top and bottom. So we've removed q b's from the top, we've got nothing left on the bottom, and so that's just b to the p minus q. The third rule, b to the power of 0 equals 1. Well, to show this we need to use division. b divided by b is 1, but b is just b to the power of 1 divided by b to the power of 1, and that is b to the power of 1 minus 1, which equals b to the power of 0. So b to the power of 0 and 1 must be the same thing. The fourth rule, b to the power of minus p is 1 over b to the power of p. We can use division again. 1 over b to the power of p is, what is 1? It's b to the 0 over b to the p. That's as a fraction. We can write the fractions as divisions. B to the 0 divided by b to the p, and then we can use the division rule to have 0 minus p, or just minus p. Rule number 5, b to the power of p all to the power of q is b to the power of p times q. Well, it might be worth doing just an example here. B to the power of 3 to the power 2 is b to the 3 times b to the 3. Okay, we've raised b to the 3 to the power 2 by writing it, multiplying by itself twice, and that's b to the 6, which is definitely b to the 2 times 3. And so in general, b to the power of p to the power of q is b to the power of p times b to the power of p times b to the power of p, and we've got q copies of that b to the power p there. So if we actually count up how many b's we've got p lots of b there, p lots of b there, p lots of b there, and all the way up to p lots of b there. How many lots of p lots of b do we have? We've got q lots. So that is just going to be b to the power of p times q. The last one, there's a couple of ways of doing it. We've got b to the power of 1 over p equals the pth root of b. Let's do it just for the case of p equals 2. We know that the square root of b times the square root of b is just b. We can also say that b to the power of a half times b to the power of a half equals b to the half plus a half, and of course a half plus a half is just 1. And b to the power of 1 is just b. So we have root b times root b is b, b to the half times b to the half is b, and that means that these two things must be the same.